This is chapter 15, example 1, and what we have here, what we need to do is design a circuit that tracks 3 constantly from whatever input it has. Also has a valid output. Valid indicates when the subtraction is valid. Now the problem with subtraction is there are some cases when if I subtract 3 from a number, it can underflow or overflow the range, the given range for 8-bit RC numbers, and we want to indicate that. We're going to cheat on that one. We already designed that circuit before. We'll design it again later. Not worry about it for now. First step is always to understand the problem, which I think we do. It's a circuit that subtracts 3 from the input, then outputs that result along with a valid bit. Then we are going to draw this black box diagram for this. I don't know how to do subtraction, but I do know how to add a negative number. So what we're interested in here is some type of addition. Of course, we only have one device that does addition. Happens to be a ripple carry adder, so we can plop that down. So we're in the inventory taking mode for this problem. This result is the same as this value over here. We need on this thing, so we'll go ahead and fill these in. Always helps to put those in there. And what do I need to do is I'm subtracting 3 from A, and so A gets directly put into this thing. It's 8 bits. So the issue is what to do with the other input. We're going to be subtracting 3, and so 3 is 0, and 8-bit 3 is 0, 0, 1. All these zeros and 2 ones. So what we want to do is take the 2's complement of this and hardwire it to the B input. So this is going to be 1, 0, 1, 1, 1, 1, 1, 1. There's the 2's complement of B. I'm going to hardwire it to that B input right here. Almost done. The issue is the circuit needs a valid output as well. The valid indicates when this result here is a meaningful number. It's always going to have a value on it. Sometimes it's not going to be valid. Sometimes it is going to be valid. So I'm essentially going to need a valid circuit here. And I designed this in the lecture notes for this problem, so I'm not going to redesign it, but I'm going to note that I need to connect the 3 sign bits from these operands, the 2 input operand sign bits and the sign bit of the output. It needs to connect to the input of this box. So the notion here, I think I'll come around here just because I'm running out of space. There's 6 valid cases, there's 2 invalid cases. It's invalid when I have 2 numbers of the same sign and I get a result of a different sign. So we designed that before, we're not going to do it again. At that point, we're going to call this problem done because it's a happy problem. Issue here is keep in mind that this A is this A, this valid is that valid. So this is the top level, and this is the lower level black box diagram for this problem.